Well, good morning, everyone. Welcome to the U.S. Enterprise Mobility and Security Partner Community Call for November 2016. My name is Nick Johnson, and I am just thrilled that you have chosen to spend an hour with us today. We've got a really interesting topic. We've got a great speaker coming up. We've also got some really good community information for you. As we get started, I do want to just remind you of a couple of things. As a part of the call, you are in listen-only mode. So you can see us, you can hear us through your web browser. If you're having any issues with the audio, you can also dial in, and I'll post the dial-in information into the messages pane here in a second. Speaking of the messages pane, if you want to post any questions or feedback for our speakers or for us as moderators during today's call, down in the lower left-hand portion of your browser, you should see a messages section. Go ahead and type that in, and we'll just have a one-to-one dialogue with you. And also during our Q&A time with our speaker, you'll be able to post your questions there. Today's call is being recorded, so if you don't want to be part of a recorded call, you should go ahead and disconnect now. We will post the slide deck, and I will post the link for you here in just a few minutes. That'll show up in that messages pane, so you'll be able to go and download that slide deck from our Yammer group. For an agenda today, I do want to again say welcome. Thanks for choosing to spend some time with us. I want to give you some community updates and a couple of really cool learning opportunities that have surfaced just here in the last couple of days that I want to make you aware of and available to you. Then we're going to dive into our primary topic for today, which is the Microsoft Azure Active Directory Premium P2, some of the new features that are a part of that. As you know, sort of this month, last month, and throughout this fall season, we've been focusing on the new EMS E5 features, and this is kind of the last in that series. If you've missed any of that, you can go back and watch our videos. They're on our YouTube channel. They're on our Yammer group. If you can't find them on Yammer, just ping me. My name is Nick Johnson. On the Yammer group, happy to connect you with those as well if you want to follow up with any of those. We've also got all the slide decks and things posted. And then before we get finished up today, I also want to give you a preview of what we're going to talk about next month, because I think this is going to be a really interesting topic for a lot of partners in a really useful way. So let's take a look at some of the updates and the learning opportunities that there are available for us out there. Just a reminder, you are here at the community, and as a part of the community, we are really committed to making sure you're connected to the latest information all the way through the sales cycle and the technical implementation and deployment parts of the various projects and solutions you might be building for customers. And so to facilitate that, we really engage with you three ways. We've got a Yammer group, and that Yammer group continues to grow every single month. So if you're not a part of that yet, there's the short link right on the screen, aka.ms/US EMS Yammer. You can just go ahead and join us there. We'd love to have you there. We've got several hundred folks who've already made a choice to join us there, and that continues to grow every single month. We also have a blog. We've been posting blogs on a very regular basis, and the blogs are chock full of links to videos, to other websites, to things that you might find useful on specific topics. So be sure to follow that blog. We also do post all the links back to the Yammer group, so if you're looking for one-stop shopping, that Yammer group is the place to do that. And then we've got this call. We've got a call every single month. You're here today, so you found this month's call. We also have one coming up in December, and in December we're going to do it a little bit earlier because of the holiday season at the end of the month. We're going to actually move our call up a few weeks. So if you're looking for us at the end of the month, you may have missed us. We'll be actually on December 14th next month, so we'll be a little bit earlier than normal. But we want to invite you to join us for that as well. And you can sign up for all the calls now through the end of next June. So a couple training opportunities I want to make you aware of. One of the things is actually one of our other community leads, Rob, has been working really hard to put together this learning path. It's actually just an Excel file right now full of links. And so we're going to continue to enhance that for you, but we want to, in the spirit of just sharing what we've got with the community, get this out for you. And so you can see the short link there. This is actually just a link to an Excel file that sits up on our Yammer group. If you're interested in getting sort of started on any type of an EMS learning plan or path, if you want to pull up any sort of spot information where you're just, oh, I need to learn something about Azure Information Protection today, this file is there for you, right? We've gone through and sourced out what is the training, how long is it, what sort of technical level can you expect from it, where do you find it, what's the training modality, how long will it take you to go through it, and that sort of thing. So if you're either looking to learn for yourself, or maybe you're someone who's helping those around you build out a learning plan, this is a really great resource. We are going to continue to update this on a very regular basis for our community. And so you'll always be able to go to that learning path short link that I've got on the screen there. And you can expect to get the latest version of it whenever you download it, because we'll continue just to update that link with the latest file. So this is a really great resource. Check it out. Give us feedback. If you find some great training out there on EMS and you think, wow, this actually might benefit the community, this is not a Microsoft pushing a learning path at our partners. This is us as an EMS community building a learning path together. So if you have feedback, again, just feel free to send it to us on Yammer, and we'd love to get that included in there. The other training training opportunity I want to share with you is something that's very specifically coming up here. Our Microsoft Partner Services team, you may or may not have heard of them, but that's a group of technical experts that put together things that are a part of your MPN benefit package. And part of what they deliver is regular training courses. And this one in particular is going to be a deep dive on EMS, and it's a 3-day online engagement with live trainers, but it's online, so you don't have to travel. And it's going to give you sort of a deep dive into the latest technologies, the latest changes on EMS, that type of thing. So there's a registration link. I'm going to post this in the chat window here after I turn the presentation over to our next speaker. Go check that out. This is just brand new. It's just announced. So if you don't see a day or time that works for you yet, keep checking back, because they're actively adding more engagements right now. I think there's 4 or 5 that are scheduled around the world over the next month or two. They're going to be adding more as time goes on. So again, check this out. It's a really great opportunity for partners. You can get access to it. It's not for customers at this point. It is a partner-facing event, so it's going to be very specifically tailored to you. And next month, I want to give you just sort of a preview here, is that we've got a topic that's sort of been really relevant in a lot of the conversations that we from Microsoft have been having individually with you guys as partners lately. And so we thought we'd pull it all together and bring it up for the whole group. And so we're actually going to give you sort of a tips and tricks session about some of the kind of the top 5 things that we have been seeing in play for partners that are going to help you be most effective in your EMS learning, your engagements, your customer conversations, and so on. And so you can see on the screen there the 5 things that we're going to cover. So we're going to hit those pretty quickly next month on our community call. I actually just wrote a blog that is going to go up next week as well, so be paying attention to that blog in the Yammer site, and we'll get that link out to you. It's being edited right now. That's going to go into each of these in a little more depth. What we really want to do is sort of fill up your toolbox, right, and give you really great resources to help drive your EMS engagement. So be looking for that next month. We're already just very excited to be preparing to bring that topic out to you. And with that, I'm going to get out of the way, and I'm actually going to bring my friend Sergei Sigelnitsky on the phone. And Sergei is one of our cloud solution architects who focuses on the EMS solution. So he's spending every day deep diving into the technology. And Sergei wrote a blog earlier this month about our Azure Identity Protection, and he's actually going to bring that topic up for us today, as well as show us some demos. Again, during the presentation, if you have any questions for Sergei, you can go ahead and type those in the chat window, and he'll stop at certain points to take Q&A. So Sergei, do I have you on the phone with us still?
Yes, you do.
All right, my friend, the floor is yours.
Thank you, Nick, and great job pronouncing my last name, by the way. Hello, everyone. Good morning. Let me start presenting my screen. Can you see my screen, Nick?
We can see it now. Yeah, go ahead.
Fantastic. So the topic for today is Azure Active Directory Identity Protection. It's a new feature with Azure Active Directory available with the premium P2 subscription. And frankly, the last 2 years, the more I worked with our security solutions, Active Directory has really become my by far favorite component of EMS. And I think it brings such tremendous value to our users, to our customers, to our partners, that when identity protection came out, we tied a lot of what we've been talking about together. But before we start, let me go a little bit over why identity is such an important component of modern cybersecurity solutions and where it fits within EMS. I understand that the folks on this call are probably familiar with EMS, so I will keep this short. There is plenty of materials in the learning path that Rob has put together to kind of deep dive into this a little bit more. But the idea is that in the modern world, we're no longer dealing with applications or users that are confined to our on-premises offices or data centers. In the past, when we looked at risks to our systems, almost relied on users being on premises, users' geographical location, as a second factor for authentication when people log on and access whatever resources they need to access. Over the last 3 or 4 years, as folks migrated to using cloud applications, software as a service, or whether it's Microsoft or third party, data itself migrated outside of our data centers, and at the same time, working remotely or working from home has become much more acceptable within corporate culture, and so both our users and our data have left the premises. As we started with the Office 365 journey, for example, in the initial engagement with the migration to Office 365, we frequently had these requests to constrain logins to only users that are on premises to maintain that pseudo second factor authentication for people logging on to Office 365. But a lot of friction for the users, and understandably so, because they're missing out on some of the benefits of being able to use these cloud technologies and their global availability by still confining your users to on-premises. So as adoption of these cloud technologies evolved, those arguments about keeping things locked down to on-premises have fallen by the wayside in many cases. And in this case, the only factor of authentication we have, the only method to really be certain that the person accessing the data is the person you intended to give access to, is authentication. In our case, when we look at Azure Active Directory, that's the one as a service provider that can connect you to all of your apps. If you look at the EMS suite as a whole, right, like there are other components to it, but every single component, whether it's Azure information protection that leverages Active Directory on the back end to verify that the user opening the file, the user you decided to share the file with, is the user you intended to give access to. Whether it's a cloud app security where we're looking at who those users are when they're signing on to various cloud apps and what policies apply to them. Whether it's Intune, all of these components tie back to Azure Active Directory as the cornerstone that enables all these other technologies to protect your business or your customer's business. Advanced threat analytics is kind of a throwback in this case, and I don't mean it in a bad way, but I mean it in the way that works beyond premises Active Directory, but it brings some of the same protections and some of the same intelligence that's built into Azure Active Directory to your on-premises Active Directory. One of the reasons that Azure Active Directory provides us with the level of protection for our identities that's above and beyond what we're able to achieve on premises within a relatively small environment of our customers, and the separated environments is the scale at which it operates and the scale at which Microsoft operates. So if you think even our largest customers, if they have 1 million users in Active Directory or 2 million, I'm not aware of customers larger than that, and I think that's about the limit that's been tapped. Compare that to the scale that we operate as Microsoft, we look at processing 14 billion sign-ins per day and analyzing 10 terabytes of data and deflecting 1.5 million attacks. That is a really number. So if you do the math, 0.1% of logins that are coming in have some level of risk attached to them, and that's the level of protection that we're able to extend to Azure Active Directory, where we're able to pick that up by analyzing all of this data, learning from it, and extend it to our customers. And the only way we're able to do it, when you think of the amount of data that's coming in, is by leveraging machine learning. As I talk to partners, customers, this comes up quite frequently, whether it's just a kind of fully. What is machine learning, and why does it matter to my identity, right? If you think about some of the systems we've used in the past, when we define static rules about conditional access to your environment, or if you any kind of network access control devices, where you could define very granular rules about who is able to access your network, who is able to access different parts of your network, and what criteria you will use to allow or disallow access. Some of the same technology is present in Azure Active Directory, but the scale, if you think implementation of it at scale, being able to do it in a way that's agile and that allows us to respond to threats in a matter of minutes rather than in a matter of days, that's where machine learning comes in. So if we think about a traditional, how this would work without being able to leverage machine learning, right? We have logins coming into Azure Active Directory, and the classifier, this piece right here, that is the algorithm that makes a decision of whether or not the login that's coming in is good or bad. So the obvious bad login is you've entered the wrong password, right? That's obvious. We don't have to worry about it too much. But if it's a login coming from a different location, or a login coming from a potentially infected device or something like that, that's the type of evaluation that classifier executes. And if we look at that set of rules as something that's defined by an IT administrator, a security analyst, or a developer, it's a static set of rules. And as those rules are applied, we have logs, we have reports, we have threat data, and we have massive amounts of data that we look at to be able to evaluate the decisions we make. So if our rules, we define a static set of rules, and all of a sudden users start calling in saying, hey, getting in from, let's say, the main joint machine, and I should have access to log in and access the data I need to access, but your system is denying me access. That means our static set of rules is invalid. We need to update it manually to enable our users to continue to work to be productive business. Or similarly, if all of a sudden we have a large number of locked out accounts and we really have folks getting in who are not our users, who are able to impersonate our users and log in, that will let us know that our static set of rules is not restrictive enough. And then we have to maybe have a security analyst look at it and define the new set of rules, talk to a developer who would perform some sort of an update to the classifier itself, talk to our operations team, then go and deploy the new classifier, the updated set of rules, to better protect our environment and also to keep our users productive. So if you think about that cycle of manual labor that would have to occur, it would likely take possibly weeks in order for the update to occur and for the new level of protection to become available to us, to our business, and to our users. What we do with machine learning is automate all of that. So the learner is a component of machine learning. It's actually available for data scientists and analysts to use in their applications as well for all sorts of different reasons. But what we are using it for here is to ingest all the terabytes of data from different sources, from properties across Microsoft, to analyze decisions made by the classifier that's currently running. And if we see that a large number of false negatives or false positives that we're able to identify, then on the fly we're able to update the classifier and deploy it within minutes. That if an attack on your environment begins, let's say it's mass, and if the first few attempts to log in with your user credentials get through because the classifier rules were not sufficient to stop them originally, what will happen is as the learner looks at the incoming data and defines the incoming logins as fraudulent, the update will occur almost in real time, right? So there will be some lag, obviously, because there needs to be enough aggregated data for to build a new algorithm and then deploy it and then kind of refine it over time. But this new type of an attack will hopefully go up in minutes or hours rather than in days or weeks. And to maybe illustrate it a little bit more, if this is a case of obviously all the names have been removed to protect the innocent, but an educational institution with about 8,000 accounts had 1,750 accounts compromised. They started seeing a large number of user lockouts, and when we're looking at these lockouts, we're talking about this is data on the Azure Active Directory side, right? So clearly, what's going on there. This is a graph of what the typical login activity for this organization looks like. And suddenly, at a certain point of time, saw a huge increase in the amount of failed logins. The interesting thing here was that instead of just kind of trying to log in with a single account, the attackers were going across 1,750 accounts they had compromised to try to get in, so that it was actually more difficult to detect. If they would have slowed down their attacks sufficiently to not lock users out, that first piece of data where we saw a spike in lockouts would not have occurred. And what this looked like on the back end is this is kind of a time scale with each column representing a minute. So what we saw is there was this initial test run where whoever was trying to break into this organization's Azure Active Directory or whatever systems that are being protected by Azure Active Directory did a test, right? Lasted about 20 seconds, where they tried to log in a number of times just to make sure that their system works. Then we saw that, I'm sorry, not we, the attack. Yeah, everything seems to be looking good, and they began the attack in mass. When we look at this red columns, if you will, this is where we're looking at. It was an attack coming from a new IP address. It was not something that existing classifier in Azure Active Directory has been able to recognize immediately as a threat. So the logins failed because the attacker was trying to brute force their way in. So there was a large number of failed logins, but Azure Active Directory Identity Protection has not been able to stop attacks at that point. And about 5-10 minutes into it, this blue column you see it starts going up. And the significance of the blue color on the slide is this is where updates to the classifier begin to happen, as you can see, in near real time. And as those updates go in, the machine learning gets feedback data from all the various data sources we've previously talked about, and begins to construct a better algorithm, a better set of rules that allows it to deflect those attacks, to not even allow the attacker get in, even if they manage to guess the right password. This is even from automated process. This is still kind of a trial and error process. So there were some successes. It got to about being able to deflect about 60%, and it made a change that made things worse, better, worse. Finally, within about 10 minutes, 15 minutes of the attack beginning, Azure Active Directory Identity Protection has leveraging the new set of rules, the new classifier, the new login classifier created by the machine learning learner algorithm, has been able to identify and deflect as invalid or fraudulent. Looks like 99% or more of the logins being attempted by this attacker. About the amount of work this would have taken in a manually controlled conditional access environment, where being able to identify what is going on, why we're seeing a large number of lockouts, or if there are no lockouts, right? If the logins are spaced out over enough time to prevent the lockouts from happening, to even be able to identify that we are being attacked. I imagine something like this done manually would take hours, if not days. This is the value proposition of Azure. One of the value propositions of Azure Active Directory Identity Protection is this ability to learn and adapt to the attacks, to the new variations of attacks that maybe existing sets of rules are not able to respond to. And the conditions we look at is really quite a lot, right? And real new component that we'll look at here is a piece called risk. So as users log in, a level of risk is automatically calculated for each login, and we will go deeper into it. I mean, that's from the standpoint of an administrator or a consultant that's trying to improve protection of the environment for your customers. I think you guys will really like the configuration piece of it and being able to define this risk. And so risk is defined for in several different ways. So we look at where the attacks are coming from. I'm sorry, not the attacks, the logins are coming from. Try to analyze previous login patterns for the user against new patterns, new login information, look at different configuration vulnerabilities, etc. Policies based on risk allow you to define conditional access in a manner that's probably more secure than the static conditional rules, but also allows you to reduce the friction on the users and improve their experience as they're using your enterprise application. So they're able to remain productive in more different locations in more different scenarios, while at the same time being protected. They're really quick. So this question comes up a lot around being able to export the data and trying to integrate it into your own SIEM environment. So yes, absolutely. We'll take a look at built-in reports that come with Azure Active Directory Identity Protection, but there's also capabilities to export the data into a Power BI dashboard, into SIEM, or whatever other monitoring tools the organization uses. But before I dive into the different risk levels, are there any questions? Nick?
There have not been any questions that have come in yet, but folks, just a reminder, if you have questions, down in the lower left-hand part of the browser, there's a messages button. You can go ahead and type in your questions, and we'll get those answered as soon as they come in.
All right, excellent. So I guess let me do a really quick piece so that the rest of the presentation makes sense to you. When we look at Azure Active Directory Identity Protection, and we'll come back to it, but the key point I wanted to relay now is when you as an administrator go into enable Azure Active Directory Identity Protection for your organization or for your customer's organization, the set of controls you have is relatively small. So if you out the kind of the pilot cabin with a million different switches and that's right that you can adjust, which is what traditional conditional access configuration sort of looked like. You had 1,000 different variables to account for, and to try to adjust each one just right to provide the right level of protection. What we're looking at here is really 3 sets of conditions on 2 different parameters, so 6 altogether, right? We're looking at user risk, and we're looking at sign-in risk. Each one is rated high, medium, or low, and yet different types of remediation or response that you can configure in the system when this type of risk is detected. So in terms of configuration, this is really simple compared to many other conditional access solutions. But the becomes, and rightly so, is what does low or medium risk mean, right? Like how do you define that? Like it looks great on the dashboard. We have 15 users with low risk and we have 10 users with medium risk. But what does it really mean? What's behind the scenes? And so we'll kind of go back to the deck for a little bit to try to help us better understand what it means and with understanding it will actually help us be more secure. When we look at the different risk levels, the way it's assigned is, and this is again way oversimplified chart, but it relays the basic idea behind the concept. So if the machine learning detects a particular risk with low confidence or low severity, in other words, it's something that we're not too sure that this is a problem. If it is a problem, it's probably not that big of a deal, right? Then we assign low risk to that particular event or to that particular user. When we have a high level of confidence in something, right? We're definitely sure that the user, this login, presents a high level of risk for whatever reason, but the risk itself does not present it's not something that's likely to cause a lot of damage to the organization. Or if the severity of the risk itself is very high, but our confidence in it is low, that's where we assign medium level to particular risk. When we look at something that's high confidence, high severity, that's where clearly it's high risk. To get to a little bit more details, and these are not all conditions, but these are really good examples of what different types of risks are and some of the caveats that you should be aware of and make your customers aware of when you're implementing this. So when we look at, this is really my favorite, sign-ins from infected devices, risk level low. So if you think about it, why would this be a low risk level, right? The way we identify it is we get threat data from various network providers in addition to our properties, and by working with security companies, FBI, and other law enforcement agencies, we're trying to keep track of command and control centers for various botnets. So when we look at IPs that are communicating with those command and control centers, we can be reasonably sure that those machines are either infected or being used by the hacker, right? Because otherwise, I'd be talking to the command and control centers of botnets. The risk level we assign to that event when we detect a login from one of those devices is actually low. The reason for that is that if you think about an organization, let's say you have 1,000 people in an organization that are all coming into the office, right, and they from the office, and let's say 5 machines in the organization are infected. Well, that means we will see traffic going from whatever the public-facing IP address that organization has on premises. As the network traffic leaves the organization, to us it will look like it's just coming from that address. And we will see traffic going from that organization to the command and control centers for one of these botnets. But it doesn't mean that every device in the organization is affected. And so if we, so in this case, while the risk severity is relatively low to medium, right? You probably have some malware on this device. It may not mean that your identity is compromised, but your device is probably compromised. But our level of confidence that the device you're logging in from is compromised. It's low because in cases where there are thousands of devices on the network and only 10 of them are compromised, well, only 1% of what coming in from that location would come in from an infected device. That's why the risk level assigned here is low. So when you're considering how you're going to define this policy, you choose to, let's say, you will enforce MFA on any login that has a medium risk or above assigned to it, but you will still have a visibility into these low-risk logins. Let's say you're working with a customer and you can configure a kind of like a weekly digest of various events that occurred within Azure Active Directory Identity Protection to be sent to you, or if you're looking at this data and alerts that are coming in near real time in the dashboard or in your SIM tool, if you see these low-risk events happening and you're able to identify that, oh wow, one of our customers has some infected devices on their networks, we're seeing these low-risk login events, and you will be able to see what type of low-risk event it is, right? So in this case, infected device. That may create a kind of a secondary touch point for you as a consultant organization or a managed services provider to go back to your customer and say, look, we saw some low-risk logins coming from your location, and judging by the data that we received from Azure Active Directory, it looks like you have some devices on your network that are communicating with botnet command and control centers, which means you have some devices on premises. If at that point the customer decides that they would like your assistance with helping them find those devices and clean them up, and then maybe do a broader assessment of their environment to make sure that they don't have other threats lurking under the radar that they have not been able to find before. That is additional value that you will bring to your customer, but it's also something that a customer, without having this functionality, probably would not be able to find that they have a problem until perhaps it was too late and they have a loss or some form of event that actually raises this above the level data telemetry into the level of having real business impact on the environment. Oof, low on time. I'll try to go faster. So medium risk level. This is kind of fun. So two good ones are travel to unusual locations, so where logins are coming in at the same time from different parts of the world. This may occur if users are traveling or using a new device or VPN from outside the environment. So this is the case where if you get an alert for a medium level type of login, you can obviously remediate these logins on the fly, but it would also be good at this point to follow up with the customer and to make sure that it is in fact a legitimate user using VPN or a legitimate user traveling, rather than it's an attack coming in from the outside, where you would have to take some additional steps to shore up the posture of your customer to get them better prepared to deal with that attack. And high risk level leaked credentials. This is an interesting activity and interesting work that Microsoft does, where we actually have investigators. In this case, it's not machine learning based, it's a human, almost like a digital detective based, where our, call them digital detectives, try to find credentials posted on the dark web, plain text, and once those credentials are found, right? So, yes, let me step back. So the way this happens is perhaps some company's directory got compromised, and the hacker got tens of thousands of credentials that they're now free to use, but frequently they will not reuse those credentials themselves. They will sell them to somebody else on the dark web. And credentials are actually put up for sale, and just like in many cases when you if you go to buy music on the internet and you're able to listen to the first seconds or 15 of the song, in a similar way, they will frequently post a large number of those credentials just kind of as proof that they have the credentials. So our digital detectives find those credentials when they're posted on the dark web. Clearly not in all cases, but in a large number of credentials they are able to find, it actually provides an additional level of protection to a large number of our customers. And if we define that posted credentials actually match existing Azure Active Directory credentials, in that case, we have no doubt the credential has been compromised, right? So we have a high severity of risk event, and because we actually found these compromised credentials on the dark web, we have a high level of confidence in the data itself. So risk level in this case becomes high. Again, this is not an all-encompassing list of the types of conditions, but it gives you an idea of what you can expect from the different types of events that you see, and to kind of call your attention to the fact that Azure Active Directory Identity Protection, identifying a login risk, and then executing the policy you have in place, it's not the end of the story. Frequently, it's a beginning of an investigation that you could help your customers with, to try to identify why these credentials were compromised, or why are these logins coming from these unusual locations or with unusual behavior patterns, and then do some additional work to help your customer improve their security posture to be able to be secure against whatever level of risk you've been able to identify on your network. So the way this looks, I guess let me pause really quick. Are there any questions in the meantime? We're running a little bit low on time, so what I'm going to do if there aren't any questions is do a quick demo.
Yes, there are two quick questions. One would be the machine learning that that Azure Active Directory uses. Is it the same machine learning that's being used by Advanced Threat Analytics on premises?
No, it is not. So there is. If you look at the way Advanced Threat Analytics was developed, it was an acquisition by Microsoft. So the core engine that's executed here is different. And in case of Advanced Threat Analytics, no data leaves the premises. So when all the data comes in and is aggregated by a center, the data stays there. It does not leave the network. It does not go into Azure to be run through Azure Machine Learning. All the analytics, all the user behavior analytics, and kind of all the magic happens on premises in your environment. But there is some connection in terms of when we roll out updates for Advanced Threat Analytics, we take some of the attacks that we're seeing against Azure Active Directory that we've been able to identify as a pattern, or we take some of the maybe that machine learning learner component that creates updates for the classifier. And if there is something that we found in Azure Active Directory that is applicable to the on-premises environment, that those rules or those updates get to updates for your ATA center. And when you install an update, you actually improve the ATA center's ability to learn as well as be able to identify advanced threats. So it's kind of a one-way street, right? It's not, ATA center does not have access to the same data that Azure Active Directory has. Your data does not leave the premises. But some of the lessons learned on a bigger scale in Azure Active Directory can, in cases where it makes sense, be applied to ATA center, and that's what happens with the update.
Great. Second question that came in is what happens to Azure Active Directory accounts that don't have the identity protection license, right? So are they still protected in any way, or do customers that sign up and use Azure Active Directory, do they really need to start using identity protection?
So with those accounts, if you look at what identity protection does, is it allows you to respond in real time to threats that are coming in, right? So when you're able to set policies for accounts with this protection or Azure Active Directory P2 license, be able to set policies that look at the login risk level and in real time to that event to you enforce multi-factor authentication or block access altogether. There is you're not able to set that for people without the license. You still get security reports from your Azure Active Directory, right? So if you're Office 365 customers and you've been working with that, you're probably familiar with the reports you get where you're still able to see threats against your environment and what Azure Active Directory has been able to identify as a risk, to say, or an anomalous event, but it's not something that it's kind of being able to react in real time versus being told about an event after the fact.
Okay, very good. Thank you, Sergei. Why don't you jump over to your demo if you wouldn't mind?
Absolutely. And the demo is going to be really simple. So when we the things that makes Azure Active Directory Identity Protection is appealing to me personally is the relative simplicity that kind of obfuscates the complexity of terabytes of analyzing terabytes of data with logs and analyzing data from tens, if not hundreds, of different sources. The interface and the user experience in particular is relatively simple. So in my case, I configured a policy. When we look at sign-in risk, I said that if I detect a medium risk and above, I'm going to force my users to use MFA, to multi-factor authentication. By the way, there is a little bit of risk here involved with this. Is you need to make sure that your users are registered multi-factor authentication before you enable this policy and set it to a point where it will impact your users. This review, this estimated impact tab is a very good tool. In my cases, it's a demo environment. There's not a lot of activity, but this would allow you to visualize what would happen given your current ongoing activity. It lets you see how many people, how many different logins this would impact. When you look at the overview, it identifies as vulnerability users without multi-factor authentication registration. So the system itself will help you identify the users who are not registered for MFA. What might occur is if you say that you're going to enforce MFA for medium risk logins and people without MFA registrations log in from an unknown location or from an anonymous IP address, for example, they will not be able to log in because they don't have multi-factor authentication. But I digress. So when we look at my policy is set to say that if a user risk is medium, we're going to user risk. When we see that the sign-in risk is medium, we're going to require multi-factor authentication, which is pretty reasonable, right? We have either a low confidence and a high impact of a log of high impact risk, or we have a high confidence in a low impact risk. Multi-factor authentication is not that difficult. And I have two browsers here. On the right is the best browser in the world, Edge, in private window, and on the left is Tor browser. And if you're not familiar with the Tor browser, it's a browser that's been developed to allow its users anonymous from the websites they're trying to access. So in my case, I'm accessing this MicrosoftOnline.com website, and the browser itself found a route through the Tor network that has gone through Hungary, Sweden, Greece, and from Greece, it's accessing the internet. So as far as Active Directory knows, on this browser on the left, I'm trying to log in from Greece, which I've never logged in from before. But not only that, look what happens. The login occurs more or less as hopefully as normal. Let me start again. The danger of live demos. There we go. I'm redirected to the login page that's been customized for my Azure Active Directory, where upon entering the password, I'm told that there is something unusual about my login, which is understandable since I'm logging in from Greece where I've never been before. But as you see, the messaging itself is pretty self-explanatory. So if I'm a user that's using a Tor browser and I'm a legitimate user, I can actually use multi-factor authentication at this point, and you will hopefully hear the ding of a text message arriving in any second now. And there it goes. And at this point, I'm able to access to one-time that will allow me, if I'm a legitimate user, to sign in and to use whatever the applications I have available to me and kind of just proceed as normal. However, I had to do that every single time I logged on. That would get annoying really quick. So in the browser on the right, where it's Microsoft Edge, the login is coming from a location I've logged on from before. I'm not in my signal over the world to try to remain anonymous. When I go to sign in, the same process occurs. I'm redirected to my customized there we go. And there is no MFA, right? So if the vast majority of users in the vast majority of situations, based on the evaluation of kind of metadata around their logins, the experience is very seamless. There is no MFA, they're not blocked, they're just enter their username and password, not being aware of all the work that's being done behind the scenes to keep them secure, and they're able to log right in. However, when something anomalous is detected, either enforce multi-factor authentication and just check and make sure that the user is who they say they are. And in most cases, will be really understandable to the user because they are doing something unusual. They will know if it's a legitimate user or if it's actually a hacker coming in from Greece using the Tor network to try to remain anonymous. They will be able to see that, well, I need the user's cell phone in order to be able to log in, or if you're using a different method for multi-factor authentication, the attacker would need to have access to that. So this is really simple experience. When we look at a couple of configuration items I wanted to point out, it's all the risk events you're able to see in the dashboard here, in Azure Active Directory Identity Protection, the new portal. There is about 5 to 10 minute lag between a risk event occurring and it being displayed on the dashboard. Look here, so this is from me testing this last night, and when we look at the type of event that has been identified as a risk event, it's a sign-in from anonymous IP addresses. So we're actually aware of the Tor browser network and know which IP addresses are used by that network. So when we see logins from those addresses, we automatically know that the login is not actually coming from that particular location, that it's somebody trying to rename anonymous, and we automatically increase the level of risk for that. The risk event from October 19th is a sign-in from unfamiliar location. So my lab and all the work I've been doing in my lab were done from Illinois, and I spun up a machine on the West Coast, and with one particular user, Dennis Rodman, I've only tested a user from Illinois in the past. So after 14 days, it actually learns that behavior, learns the pattern, and then when I signed in as that same user from the West Coast, the first time I sign in, it's an unfamiliar location. So the system forces MFA to make the user prove it's actually the right person and not somebody coming in from the outside. But as you can see, these events are marked as closed. So what does it mean? That means that the event occurred Azure Active Directory Identity Protection automatically remediated the risk by forcing multi-factor authentication. In cases where the level of risk is below the threshold you've set in the policy that forces automatic remediation of the risk, you would actually see those events here, right? So if I had any low-risk events that do not rise to the level where you want to force MFA, but are still something to take a look at and maybe take back to your customer to see something that needs to be addressed, you would also see them here. You're able to forward alerts automatically to users, distribution lists, weekly digest, the same thing, kind of a summary of events that have occurred during the past week that you would be able to receive, and then if it needs a follow-up, you can follow up on that and take it back to your customer to help them remain safe and add value to what Azure Active Directory Identity Protection is able to provide. And that
Sergei, we had a question come in that I think is really good for the group. Is when a user is identified with a high risk level, or medium or low or whatever, what's the process for reducing that level, right? Do you just go in and close an event, or are there specific actions that you should take against that user account?
Yeah, so that's a really good question. So there is a user flagged for risk, and there is a risk event, and those are two different things, right? So kind of if a lot of risk events occur for a particular user, then the user itself becomes flagged for risk. Can actually set a policy to remediate that. So the automatic remediation is a password change, right? Because if you think about what does it mean for a user account to be at risk? Well, at a very basic level, it means that somebody knows that user's password or username and password. So requiring the change on the fly and setting the password either immediately, or if you decide to block access and then reset user's password on the back end, that will take care of it, and at that point the risk will be reduced because the risk effectively has been remediated.
Great, thank you for that. And I don't see any other questions for the whole group in the queue here. There's just one more that popped in here. Nope, none that's in there right now.
And this is actually, so I guess to kind of go back to that just for a second, so this is a good screen or a good place to look for it. So if we look at my Michael Jordan user was marked to be at risk in the past, status, policy use password change, right? So, but because of that user did not have multi-factor authentication enabled when I was doing this back in October, the process actually could not be completed. So for me as an administrator, I would need to go back to the user, manually reset the password, have the user log in from a location where the risk level of the login itself is not medium or above, reset, register for MFA. The password has already been reset, so we're good there. And at that point, the risk has been remediated. For logins from August and September for some of my other accounts, for those users, because they were registered for MFA, we were able to change the password, the risk has been remediated and they're no longer marked as users at risk.
That is fantastic. And I know we're ending the hour here. So Sergei, thank you. This was a really, really good session. A lot of comments here just saying thank you for doing this. Partners, again, thanks for investing your time. Don't forget to sign up for our December 14th call. We're going to be doing some tips and tricks sessions there. So really, really useful stuff coming your way. And again, don't wait to ask us any questions. If you have questions about this or any other EMS topic, go ahead and post it in our Yammer group. We're happy to engage with you there. And with that, we're going to go ahead and close out the call and say have a great rest of your day.
Sounds good. Thank you, Nick. And thanks, everyone.